In this video, I will present the most beautiful equation by this person's name, and I don't want to mispronounce their name, but they're 17 years old, and that's really cool. So the golden ratio, I'm just going to write it as phi. The equation phi squared minus phi minus 1 equals 0, and the solution is positive, so phi is greater than 0. You divide by phi, leaving us with this result 1 over phi equals phi minus 1. So we're going to start with the fact that e to the I phi plus 1 equals 0, or you subtract 1 on both sides, so you get e to the I phi equals minus 1. We're going to raise the golden ratio to this power, so we get phi to the e to the I pi equals phi to the minus 1, which I'm going to rewrite as 1 over phi. And using this result here, I'm going to rewrite it as phi minus 1. So we can subtract phi on both sides, leaving us with the first equation, which I'm going to show, phi to the e to the I phi minus phi equals minus 1. And we're gonna factor out a phi on both. So when you factor this out, you get phi e to the I phi minus 1 times phi, and you factor the phi out. So you get phi e to the I phi minus 1, and you factor minus 1 and all multiplied by phi equals negative 1. Then we're going to divide by phi on both sides because phi is greater than 0. And from the result that 1 over phi equals phi minus 1, you can multiply by negative, obviously, to make negative 1 over phi equals 1 minus phi. So I just replace that with this result right here. And now, what we're going to do is we're going to add phi on both sides. So on the left-hand side will be looking like this. On the right-hand side, you get 1 plus 1. So you have to move the minus 1 to the other side. So you get 1 plus 1. That's obviously 2. And you can see how these purple equations I wrote in purple looks very similar, just slightly different. So we do the same process again. We divide by phi. And this time I just wrote that 1 over phi is phi minus 1 just so I know what to do. So you get 2 over phi, but that would be 2 parentheses phi minus 1, which is 2 phi minus 2. We subtract 2 phi, we subtract this 1 on the other side, so we get this equation, which is really interesting because it's really getting different. And so you do that again and you get this. I did it one more time. So this 3 is not the same thing as this 3. This 3 is actually just n at 3. This 3 is the Fibonacci series of 3. So I'll just show you in a sec. And the positive and negatives will be different depending on what values they are. So finally, his result was phi to the e to the I phi minus n plus parentheses negative 1 to the n plus 1 times f of n times phi equals negative 1 to the n plus 1 times f of n plus 1, where f of n is the Fibonacci sequence. So f of 0, I wrote this again, but f of 0 equals 1, f of 1 equals 1. So f of 2 will be these things added to each other, which is 1 plus 1 is 2. F of 3 is 1 plus 2, so these things will be 3. F of 4 will be f of 2 plus f of 3, which is 5. F of 5 will be 8, and so on. So that's why f of 3 is actually the same thing as 3. So, and this only works for positive integers, so n has to be an integer, which means it's a whole number, and it can't be negative because Fibonacci of a negative number is not really defined well. So that is the end of the video.